The purpose of this video is to introduce you to trusses. And so we're going to start with a piece of material, okay? So this is plastic and it's got a length to it, and of course trusses can be made out of a lot of different things. But the point is that usually the material can't support a lot of lateral force, okay? So if I took this piece of material and I just, pull it in half, it breaks apart really easy. It can't support very much force in the lateral directions. On the other hand, if I pull on it, I can pull really hard and it would start to stretch, but it wouldn't just break, okay? So it can handle a lot more pulling force, so that would be in tension. And you could also push it together. Eventually it's gonna buckle, all right? But it takes a lot more work to get that to buckle than it would be to just break it in half, all right? So that's real common for trusses. You're trying to keep the forces aligned along the member, okay? They call these the members of the truss, okay? So how do you make a truss? Well, you connect these segments or these members together. You wouldn't do it in a kind of a dumb way, all right? So here's 4 things connected together and it makes, a polygon, and there's an infinite number of polygons that can be made of equal length members, and so this thing will collapse on itself. If I just let go of it, it falls over. Okay, so you would think triangles, and I think that's what most people think of when they think of trusses, connecting triangles, all right? And so here's an example of 3 equal length members connected together to form a truss, and so you see it's rigid. If I hold it up, it doesn't fall over by itself, okay? And so when you are designing these, typically a load is applied. The load needs to fall right on one of the connection pins, okay? You wouldn't put the load at the side of the member. Why? Well, we just showed these members can't support forces in lateral directions. The force needs to go along the line of the member, okay? And so, lest you think that trusses are completely triangles, let's talk a little bit more about how you would make more complicated trusses than simply just triangles, okay? So let's start with this 4-member connection, and we can show you, or we can notice that, hang on, let me get another connection piece. If I simply take this and I form essentially 2 triangles, okay? So I put this across and I can bolt those down. I think it works better for you to go ahead and take that step. Okay, so take this nut and tighten that. These connections act like pins, okay? There's not a lot of friction to keep it from rotating, okay? But you do need to connect it to where it doesn't rotate out of the plane that the truss is in, okay? So one of the things that doesn't quite match the theory is that when I make these connections, normally we would want all the members to be in exactly the same plane, but because there's a width to each of the members and the way I'm pinning these together, that's not quite true, okay? So let me show you what I mean once I get this tightened down. Okay, so what I mean here is if you look closely, here is a member, all right, and then we have, I could have gotten rid of that nut. That would have made it a little bit more along the same plane, but this member is then connected on a slightly different plane. Okay, so ideally you'd want everything to be in the same plane. Okay, but my point is, I essentially took a triangle shape. So think about it, here's this triangle shape, and if I add 2 members to that, if I start with something rigid and I add 2 members to it, it's still rigid, okay? This one flops a little bit just because all the flopping is not in the same plane, but if you keep it pushed along the table where it stays in the same plane, it'll buckle, but it's rigid within that plane, okay? All right, so it turns out that if you start with a triangle and you add 2 members at a time, you will get what's called a simple truss, and simple trusses are rigid bodies, okay? So lest you think that all simple trusses are formed by triangles, I built another one that has a slightly different shape. So you can see one way to build this would be to start with this smaller triangle, add 2 members, okay? So it's still a simple truss, all right? And then I added 2 more members here, still a simple truss. Added 2 more members here, still a simple truss. And then finally added 2 more members on the outside here and here. So this is a simple truss because I started with a triangle and I just kept adding 2 members at a time. All right, notice that this shape where these 4 things are pinned together, that is not a triangle, okay? So it doesn't necessarily follow that all simple trusses are built solely comprised of triangles. Okay, so if I had this is a rigid structure. I can apply forces on it, okay? And it's interesting if you're gonna get these parts sent to you. If you put something together, you can see the parts that are under compression because those are the ones that tend to buckle. All right, so I add a little force on the pins and I can see it start to buckle in different places. If I pull, things are under tension, and you still get some things that buckle. It's just the different members buckle. So you can play around with that and kind of think about what's under tension and what's under compression. Okay, so just to be clear, if I take something like this and I push it together, it's under compression. So external forces pushing together, it's under compression. And it'd be subject to buckling. All right, if I take this and I pull on it, all right, pull it apart, it's under tension, and especially because this is plastic, it'd be subject to stretching and then failure from that point. Okay, so there's a simple video to introduce trusses to you. Of course, our idea here is that we want to apply engineering principles to get to where we build something like a little bridge structure, all right? And that's gonna be part of another one of your design projects. So that's where we're heading. And so the next video, we're gonna talk about how to analyze trusses using a technique called the method of joints.